Hi everyone, Mr. Smith here, and in this quick hits video, we're going to find the derivative of a function using the definition. So as I write this, I know my calculus and vectors class, we're kind of just have been focusing on, hey, how do we find the instantaneous rate of change of a function? How do we estimate it by looking at average rates of change? Or in other words, we've been looking at how slopes of secants get closer to approximating the slope of a tangent line. And we've been developing algebraic ways to do this, and we've reached kind of the pinnacle, the definition of the derivative, a way to actually find the slope of a tangent line to a curve at a point. And what the derivative is, it's actually a function itself. The derivative function f prime x, it is a function, and it gives you not just the slope of the tangent at any one point for a function, but at any point x. So you can just plug in what if you want to know the x value or the slope of the tangent line at x equals 2, you find the derivative, you plug in 2. And if you want to find it at 3, 4, 5, and 6, you don't have to keep doing difference quotients over and over again. You can just use the derivative. We will be developing rules for calculating derivatives very easily and efficiently. Right now, we are focusing on having a good understanding of the derivative function. And I'm going to do an example here, finding the derivative of 2 root x. And I think I'll just work straight down from the definition I have here. So let's begin. So the derivative of this function, so the limit as h approaches 0, f of x plus h would be 2 times the root of x plus h. The function f of x minus 2 root x all over h. I might actually go and just give myself some space here. So our strategy for evaluating indeterminate limits like this, where we have radicals, was to multiply by the conjugate. What is the conjugate of 2 root x plus h minus 2 root x? It's this, 2 root x plus h plus 2 root x. Got to do the same thing at the bottom. 2 root x plus h plus 2 root x. And now we do some simplifying. What we always get on top, because the top is a difference of squares, we're going to have 2 root x plus h times itself. That will give us 4 times x plus h. The cross terms will add to 0. The cross terms would be 4 root x plus h root x. We'll have a plus and a minus. They'll add to 0. And then we have negative 2 root x times positive 2 root x. This would just be negative 4x. On the bottom, h, and then 2 root x plus h plus 2 root x. And now we do some cleaning up. When finding a derivative from first principles, you will always be able to divide out the h on the bottom. And here you can see on the top, you get 4x plus 4h minus 4x all over h times 2 root x plus h plus 2 root x. And I might do a few things at once here. So 4x minus 4x is 0. And then look, now we're going to have h over h. They divide out. And what you'll be left with, you could do that in 2 steps as well if it made you feel more comfortable. We're just going to have 4 left on top, all over 2 root x plus h plus 2 root x. This is something that we can plug h equals 0 into. We get 4 over 2 root x plus 0 is just x plus 2 root x. Keep simplifying. 2 root x plus 2 root x is 4 root x. And the 4 on top and the bottom divide out, and we're just left with 1 over root x. So very cool. The derivative of 2 root x is 1 divided by root x. And now you have the slope of the tangent line wherever you want. Just at the tip of your fingers. Just plug in the x value and you've got it. and that was finding the derivative from first principles. We want to get comfortable doing this so we have a good understanding of where our derivative rules come from in the future, but we are very close to developing rules to find derivatives like this one, not in a few minutes, but in literally a matter of seconds. But we're almost there. So this was a quick hits video on the definition of the derivative and finding a derivative from first principles. See you guys in class.